Hello everyone. I'm gathering some old batteries. You might think dead batteries are only good for the recycling bin. Instead of throwing them away, I'm going to extract valuable components that we can repurpose into something truly amazing and useful. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'm taking one of the batteries and securing it into my drill. The goal here is to carefully cut off the battery terminals with a small saw. This makes it easier for me to cut the positive terminal of the battery, which is essential for the next step we will take. Next, I'm carefully removing the outer metal casing. This exposes the inner carbon rod, which is the key material we need for conductivity. Now, I'm using a small screwdriver to scrape out the black graphite powder from the inside of the batteries onto a piece of paper. This is pure carbon, and it's an excellent electrical conductor, vital for our project. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm transferring the collected graphite powder into a small pan. I'll place it on an induction cooktop and gently stir it with a wooden spoon. Heating it helps refine the graphite and enhance its conductive properties. Once heated, I'm moving the refined graphite powder into a small metal bowl. I will use the back of the screwdriver to grind the powder into a fine powder. This will create a small, smooth, and stable carbon electrode, perfect for our device. I'm taking a battery casing, a carbon rod, and some baking soda. I put the baking soda into the battery casing. I'm adding a drop of super glue onto the baking soda, then pressing a small metal piece into it. The glue acts as a binder, creating a solid, highly conductive tip for one of our leads. I repeated the process of adding baking soda and super glue to firmly secure the carbon rod. I'm preparing the carbon rod by sharpening it on a grinding disc. This will give us another conductive soldering iron to test later. Next, I'm taking a red electrical wire with alligator clips. I strip a small section of the wire and attach it securely to the carbon rod we just created. Then, I secure the connection with electrical tape for insulation and safety. I'm doing the same process with a blue electrical wire and the other alligator clip. This time, I'll attach an alligator clip to the other end of the wire. Now for the moment of truth. I'm connecting the alligator clips to a Makita battery. The red clip goes to positive, the blue to negative. Watch closely as I touch the soldering iron tip to the negative terminal of the ground connector. See that spark? That's the power. I'm placing 2 razor blades on a wooden board. Look how it instantly heats up and melts through the razor blade. This tiny tool is incredibly powerful. I'll attach another razor blade. When I touched the pointed tip to the blade, you could see the concentrated heat melt and fuse it instantly. Moving on to another application, I'm taking a small mesh screen and tracing its shape onto a plastic battery casing using a marker. I then carefully cut the mesh to size with scissors to create a custom conductive plate. When I touch the pointy tip to the mesh, you can see the concentrated heat melting the plastic instantly. This demonstrates its potential as a precision heat soldering iron for melting plastics. I'm applying masking tape to create a design on a plastic surface, effectively masking off an area. This is an important step in determining the repair space. I'm carefully filling the masked area with the refined graphite powder, then adding drops of superglue over it. The glue rapidly cures the powder, forming a solid conductive patch within our design. I repeated the process of adding carbon powder and superglue until it was full. Once hardened, I'm sanding the newly formed conductive surface. This smooths out any imperfections and ensures optimal contact for electrical conductivity. Finally, I'm using a permanent marker to color the entire repaired area black, blending it seamlessly with the original plastic casing. This gives it a clean, professional finish. And there you have it. From old batteries, we've created several incredible tools for soldering, and even making custom conductive repairs. This DIY project proves that with a little creativity, you can achieve truly amazing things. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.